Hello everyone, this is Ahmad Almousa, and in this video we'll talk about imperfections in solids. So in this video we'll talk about the definition of materials defects and the types of defects, and we'll show some examples of those defects, and most important we'll talk about the importance of studying those different types of defects and why they're important to us. So first of all, what's a defect? Defects can be basically described as any irregular arrangement of atoms in a crystal, and they form when the crystals are forming because particles don't have enough time to arrange themselves in a regular pattern, and that's due to the temperature. All crystals are imperfect. Only at the absolute temperature or 0 Kelvin degrees a crystal might be perfect. So there are three types of defects: a point defect, line defects, area defects. And you'll talk about each one of them in the next slides. The first type we have point defects. You can think of it as defects at an atom level. So we have vacancy atoms. That's the first type of point defect, and this basically means there's an empty site in the crystal. There's supposed to be an atom, but it's empty, causing deformation around that site. The second type is interstitial atoms. So as you can see here from the Frankel pair defect, there's usually an atom right here, and it moves to a different location, causing a vacancy atom, a vacancy site right here, and causing an interstitial, self-interstitial atom right here. Another type of the interstitial atom is the impurity, and this basically means the same as self-interstitial, with the exception of the atom is actually from a different element, so it's the same as this, but it usually is smaller. That's why it's called impurity. Um, the the last type of point defect is the substitutional atoms, and they're basically atoms from different elements that substitute atoms from the main element. So they might be bigger, might be smaller, causing deformation, as you can see here in this picture. So the second main type of defects is the line defects. Line defects or dislocations, you can think of them as having a line of atoms defect. So in edge dislocation, there's an extra half plane right here, causing this part right here to have less area than this part. As you can see, there's deformation in this crystal. The second type is screw dislocation, and this basically is a slip deformation caused by shear stress. So the last type of defects we have is area defects or grain boundaries. So when crystals were forming, the crystals keep growing until they hit each other, and they're separated by those lines, which we call them grain boundaries. So in this picture there are three. There's one, two, three different crystals with different orientations, and they're separated by this grain boundary. So why are defects important to us? So defects determine the physical properties of material. So adding manipulating different materials, causing different defects, cause different physical properties from the original one. Physical properties like stiffness, density, etc., or thermal resistance. And also catalyst sites are usually surface defects. So a rate of reaction will be different from one metal to another depending on the defects. And an example of why it's important: high vacancy concentration in a metal can decrease the ductility or the ability to be reformed without losing toughness. You can think of ductility as the ability to make a wire be reformed to a wire without losing its stiffness, like copper wire. So high vacancy concentration can decrease the ductility but increase the hardness. So depending on what you want from the metal to be, to function, you can actually choose which metal will be the best for that. So that was it for this presentation. We'll now take a look at the 3D model. So as you can see, there's a 3D model right here. There's blue atoms are basically atoms from the same element. We have a vacancy atom, as you can see here. There's an atom that's not present in this area, and we have also a impurity right here. That's an impurity. It's basically between the atoms and from a different element. The one in red is a self-interstitial. I put it in red just so you can see so you can see it. This is self-interstitial, and it also can be an impurity, but with a bigger size from the different element. So that was it for today's video. Hope you enjoyed it, and thanks for watching.